This is going to be the power supply case for Tech 4472. We're going to design a sheet metal case that will house some sort of power supply or, I don't know, some electronic device. So we've got our power and switch fuse hookup. We've got some ventilation. And then on this side, we've got our fan and a grommet for wires coming in and out, right? So, this would all be parts that we've spec'd out or selected some for other reasons. All we're designing is just the housing to actually contain everything, okay? So let's jump on in and design this. I've got everything laid out already. This would be things that you could just look at the part drawing for the components that you select, and you can see the bolt patterns, or if you have them already, you can just measure out the bolt patterns or the hole patterns and see where things need to go. So that's already been done. All we're going to be doing is following the drawing. So in NX, we've started a new file. We are in inches. This is a sheet metal part. File name, sheet metal case is fine, and save this to a place that you can actually access later. Say okay. Now we're told on the drawing that we're dealing with material that is 0.06 inches thick. So we're going to go ahead and change that in our preferences. So we'll go to File. Over on the right, we should see Preferences. We'll see Sheet Metal. And we're going to make sure that material thickness is 0.06. We're going to do 0.06 for all of our values here. So 0.06 for everything. We'll say OK. All right, we'll go ahead and start off with a tab. We'll go to our sketch section on our top plane. Go to our rectangle tool. And we'll make a rectangle starting at our origin. And we'll dimension this 6 inches by 6 inches. And we'll say finish. And now we've got our main tab, or our main base, that we can then make our flanges from. Now everything's going to fit inside this 6-inch box. We'll say okay. If we look at our drawing, so this 6 inch by 6 inch is defining, the entire size of our box. Everything else will be enclosed inside this 6-inch square. Now on this, we have two main sides. Okay, so we've got like this side and then this side, and then we have these smaller flanges on the edges of those. Let's start off with the two main sides that all of our components are going to be on. Now those are both 3 inches tall. Remember, everything's enclosed inside the 6-inch square, and the 3 inches is measuring from the bottom of the box to the top. So those are the things we need to keep in mind when we make our flange. So we'll go to flange. I'll select the top line on one side and then the top line on the other side. Our length is going to be 3 inches. Length reference. So remember, the length reference is asking us, well, where is that 3 inches starting from? So remember, we have inside, we have outside. You can kind of see here with this what it's referencing. Inside versus is going to be the inside of our base. Outside meaning the outside of the base. So that 3 inches is referencing from the bottom to the top. So it is going to be outside. And then our inset is going to be referencing, where this bend is located at. If we do material outside, the inside face of our flange is going to be on the outside of the base. Material inside is going to be where everything's inside our base area. So that's what we want. We want 3 inches for our length, full for our width option. Length reference outside, inset is material inside. We want all the material inside. And we'll say okay. Now let's start working on the holes for this face. So we'll do this face first, and then we'll do this other face. So this face has the hole for the fan, the holes for the bolt of the fan, they're the bolts for the fan mounting, and then also the hole for the grommet as well. So let's do the large hole first. Now this is a 2.36 inch diameter hole. It's a through hole. So we're told that everything's located, or everything. This hole is located horizontally aligned to the face, and it's over 2 inches. So back in NX, we'll go to the modeling area. We have more hole. Simple hole is fine. We're going to use a custom size. .36 inches. We'll go to our sketch section. We're going to sketch the center point of this hole on one of the faces of our flanges. Say okay. I'll just place a point somewhere in the middle. I'm going to align this horizontally with the midpoint of this line. So I will create persistent relations. And I'll go to make midpoint aligned. Make midpoint aligned, I'll select our point. And I want to select this face edge. You can see like it starts here at the origin, and then it goes down to where this face ends, right where the bend begins. So that's the line that I want to select. That's the edge that I want to select. I'll say okay. And this is 2 inches over from that edge. So I'll distance that out 2 inches. Sketch is fully defined. I'll say finish. Our depth limit, we'll say until next. That'll go through just the sheet metal part. We'll say okay. Next, we have 4 of the 0.17 inch diameter holes. These are located on a 1.968 inch square, located centrally around the hole that we just added in. So we'll go back to our hole tool. This time we're doing a hole diameter of 0.17. We'll go back to our sketch section, sketching on the same face. And this will be on a square bolt pattern centered around the center of this arc. So I'm not going to lay down a sketch point. So I'm going to go to a rectangle, make a square located centrally around our hole here. I'll go to a make midpoint aligned. I'll select one of the top lines, and then the arc center, I'll say apply, and then one of my vertical lines for the arc center, and I'll say okay. Now the box itself is located centrally around the center of our hole, and I'll dimension these accordingly. .968 and 1.968. Now this is reference geometry, so I'll go ahead and select all of these lines and say convert to reference. And then I'll add a point at each of the corners. We have 4 points, everything's fully defined. I'll say finish. Until next for the depth limit. And I can say okay. So there is the hole for our fan and the 4 holes for the bolts that are going to mount the fan to our case. Last thing on this side is we have a 3/4 inch hole that is located an inch away from our side here, and then 0.87 inches up from the bottom. So we'll go back to our hole tool. Use a hole diameter of 0.75. We'll go back to that same sketch surface. This time we can just put a point down, and we'll dimension this point from the side of the box, 1 inches. And then from the bottom of the box, 0.87. Inch over, 0.87 inches up. Sketch is fully defined. We'll say finish. 0.75 inches until next. Say OK. That is where the grommet is going to go. Now let's look at our other side. The other side has a cutout for our power hookup and our switch. And then it also has the cutouts here for ventilation. We've got this like honeycomb grid. Both of these, so this rectangle here, this cutout, it's got a couple of holes. Everything is located horizontally aligned. This honeycomb pattern is on a 1.5 inch by 1.5 inch square grid that's also located horizontally aligned. Let's focus on, let's do the cutout for our power, and then we can look at the honeycomb. So this is a 1.85 by 1.11 inch rectangle, horizontally aligned, and it starts in an inch over from the edge. And then we have 2 holes here for the mounting that are 2.2 inches apart. So to do that rectangle cutout, obviously we can't go to the hole tool. So we'll go to normal cutout, and normal cutout, we are going to go to our sketch section, and we're going to sketch on the other face, the other side of our box. I'll make a rectangle here. I'll dimension this 1.85 and 1.11. This needs to be aligned horizontally with this line. So I'll go to a midpoint aligned. I'll pick up the midpoint of this line on the left, this 1.11 inch line, and I'll select the vertical line of our box. So now it's located where it's aligned horizontally. And this is going to be located an inch over from the edge. So our box is 1.85 by 1.11. It's aligned horizontally, and we are located 1 inch over from the left of our box. I'll say finish. Cutout method, thickness, limits until next. So we'll say OK. There's our cutout for our power supply, our power cord and switch and fuse combo. Next we have the 2 mounting holes for this. These are actually threaded 440s. So we'll go to more, go to the hole. We want threaded holes here. We want inch UNC size 440. And we can specify point sketch section on that face. And this time we're going to use a line to reference these hole locations. So I'll just draw a line. And I want the midpoint of this line to be located at the center of this rectangle, right? So I want it to be like here, right? Because it needs to be aligned horizontally and vertically. Everything needs to be centered. So I'll use my make midpoint aligned, the midpoint of our line, and I'll select both of these, the horizontal and vertical lines here in 2 different operations. So I'll say apply. And I'll select the midpoint again and select our vertical line. I'll say OK. Now, so as the size of the line changes, it's symmetrical on each side. We can make this the distance between the 2 which is going to be 2.2. So we'll say 2.2. This is going to be reference geometry because this is only going to be locating our 2 points. And we'll go to our point tool and we'll add in a point for each of the ends. I'll close out of that. Sketch is fully defined and we'll say finish. And there is our 2 440 holes. Now for our vent design, we will create a hexagon shape here, and we'll be able to use the pattern feature to space everything out. We are going to use a grid for our 1.5 inch square, just so that we can position this accordingly, so everything is centered and positioned correctly. But we'll actually use the pattern feature to create the rest of these. So we'll make one and then use pattern feature for the rest. So we'll go back to normal cutout, sketch section. On that same face, I'll make a square. This will be 1.5 by 1.5. I'll say make midpoint aligned. The midpoint of this line to our end, our vertical line on this side. So this line here, that edge of our box. And the box itself, so that 1.5 inch square, is located 0.75 inches from the edge. So I'll select that line, that edge, and we'll say 0.75. Now this right here is just reference geometry. This is just allowing us to locate the location of our first hexagon. So we will convert that to reference. We'll come up here to more, where we can go to our polygon. I want a 6-sided polygon, and I want the polygon to start at this point. Technically, you could do any corner. I'm gonna do the top right-hand corner. I wanted to start at that point, and I'll just place it somewhere. So no constraints are added into this right now, and I'll close that out. Now I want one of the flats to be horizontal. So I'll say make horizontal, and I'll select this top line here. That's going to make it to where that line is always horizontal. Say okay. And then the distance between flats is 0.2. That's our distance between the flats. Sketch is fully defined. I can say finish. And I'll say okay. And that is our first cutout for the vent here. To create the rest of the hexagon shapes here, we'll go to pattern feature. The feature that we want to pattern is going to be the hexagon shape here. Remember, you can select it in the part navigator or click it, like actually select it on the screen. Either way. The layout that we want is linear. Direction 1, where we specify a vector, I'm going to choose, looking at it from like this, the left direction. So I want this to be adding, patterning this feature to the left. I'll choose that direction. We want count and span because this is going to, if we look at our drawing here, this is the 1.5 inch grid that we have. This is like the beginning and the end. So we're spanning a total distance of 1.5 inches on both sides. So count and span, we have 1.5 inches for our span distance, and our count is going to be 5. We have 5 of our features here. So if I say show results, that looks right for the for the distance, or at least for that one line. But we need them to be also in the vertical direction as well. So we'll use use direction 2. Direction 2 is going to be going down. I want these to be going down. This is also count and span. Our count is actually 6. And our span distance is still 1.5. If I say show results now, this is close to what we're after, but not quite, right? On our drawing, we actually have these staggered. So we can do that in this same tool here, so we don't have to do anything else. If we scroll down to pattern settings, we'll see stagger. So if we change that, so if we have direction 1, direction 2 as to the stagger direction. So we do direction 1, we're going to be staggering our instances here. We can also change show last line of instance. So if we have that on, notice that it adds that last instance point. If we leave it off, it leaves off that last instance. We're going to leave that off. So we went to pattern settings, stagger direction 1. Now let's say show results, see what that looks like. That looks better. That's what we're after. So we'll say okay on that. There are it's our vent holes. Now we have the small flange on both sides. It is 1/2 inch length, and it goes all the way around on both sides. We also have a mitered edge between these short flanges. So back at our box, we'll go to our flange. We want a length of 1/2 inch. And we'll select our lines. We can actually select all of our lines here. So we want the inside edge of each of our faces. Get them on the other side too. And if we think of our length reference and our inset, length reference means that this 1/2 inch is judging from the, this outside face to the top, and that's what the 1/2 inch was describing to us. And the material inside keeps everything inside essentially this base that we still have. So now everything is still 6 inch by 6 inch. So that's what we're after as well. You can kind of see that here. So if I change material outside, notice where the bend is locating at. Remember this base here is our 6 inch base. So we want everything to be inside that. So 1/2 inch, 90 degree, outside for our length reference, material inside for our inset. And I can say okay. With that though, you'll notice that our edges are not mitered. So to miter that edge, we'll go to corner, go to more, should see 3 bend corner. The 3 bend corner, what this does, it essentially changes the way that the bend is created and also how it assembles together. So the treatment that we have, you can change the how the corner is made with the cutout. We can just leave ours open. We'll select the bends that we want the corner to be made on. So for instance, on this corner here, I can select these 2 lines or these 2 bends, and it sees that, with this bend and this bend, these two flanges connect, and we need to add a miter here. Okay. Now, if I change the treatment here, you can sort of see the difference that's being made with the specific cutout. Okay, we are just going to leave ours open. Okay, we're not going to change that right now. We just want them to be mitered. In this one operation, you can actually go and select all of your corners. So we'll go through and select all of the bins that have, so the bins that create where the miter is going to be. So this bend and this bend makes these two flanges touch. That's where we actually need the miter. So all of our bins have been created. I'll say OK. And now we have mitered edges on all of our flanges. All right, last we have is the holes on those flanges that we just added in. So those short flanges. These are also 440s. The top one here is located 0.2 inches from this edge and then 1/4 inch from the top edge. This one is located 0.2 inches from this top edge and then 1/4 inch over from the flange edge here. We will add in these two holes and then we can actually mirror the feature across the plane, mid-plane, and then mirror all 4 to the other side. So we don't have to make all 8 holes. We'll make 2 and mirror the rest. So back in NX, we'll go to our modeling, we'll go to more, hole. We want our 440s, 440 threaded hole. We'll go to sketch section. I just want to make sure that we're sketching on the top surface of the flange, the short flange that we just made. I'm going to add a point here and then down here. And I'm going to position these according to the drawing. This is 0.25 and then 0.2 from this edge. And this one's located 0.2 from the top, and then 0.25 from the edge. Remember, if you can't access the edges here, right? So if you can't access an edge of the extrude, make sure that your scope is changed from within Active Sketch to within Work Part or Assembly. And you'll be able to access the edges. The sketch is fully defined. I'll say finish. Our depth limit should still be until next. We'll say okay. Now we've got our 2 holes here. And I'll say mirror feature. And the feature that I want to mirror is these 2 440 holes that we have. When I go to specify plane, I don't have the mid plane that I want, right? I need a plane that goes right down the center here. But we have new plane selected, and the type of plane that I want is a bisector plane. Or with bisector, we choose 2 planes or surfaces, and it adds a plane between those 2 surfaces. So if I select like the outside of the box on this side, and then the outside of the box on this side, it's going to add a plane right down the center. And that's what we want. So we can say okay, and it's going to copy, mirror these holes onto this side. And we'll do the same thing for the other side of our box. So we'll go to mirror feature. And what do I want to mirror? Well, these 440 holes and also these 440 holes. So I've got all 4 holes selected. Specify plane. I want a new plane, bisector. This time I'll choose the other surfaces, so the short flanges that we just selected or just made. So notice that so I selected those two faces and the plane is right here. Remember, when we make a plane, the limits of the plane are not shown just by this rectangle here. The limits go forever. So this is fine. So I can say okay. And there are the holes on the other side. All right, last thing that we'll need to do is make a flat pattern for this. So we'll make a flat pattern. The upward face I want is just the top of the base. I can say okay. Remember, the flat pattern is in your model views. And here is our flat pattern. We can export this as a DXF file, which you will need to do for the assignment. So make sure that you export this as a DXF, save it somewhere that you can access, because you'll need to submit that as well.